Good morning, children. Welcome to online classes. DO Nalgonda YouTube channel. My name is Siraj Kumar. I am working as postgrad teacher in physics, Telangana State Model School, Tipati. Right. Today I will teach you the topic of 9th class 4th chapter, that is refraction of light at plane surfaces. Okay, refraction of light at plane surfaces. So in this class today, we will discuss about what do you mean by refraction of light, how it takes place. So before going to in detail, we already know that. See, for example, here this is a glass. This is a glass, and I am keeping pencil here. So when you look through this pencil, it remains as it is. There is no change in the shape of the pencil. Am I right? Similarly, the same sense, if I pour water, so you can see that here you can see that the pencil is somewhat bended. Am I right? Okay, pencil is somewhat bended. So what is the reason for this bending of light? So it is not straight. When you keep this inside the water, it appears to be as bending one. Am I right? It appears to be bending. So what is the reason for this bending of pencil when we keep inside this water? That we are going to study about. And another case that when same this 5 rupees coin, when you keep inside the water, and when you observe from top, it appears to be raised, somewhat raised from the bottom level, somewhat raised. Okay, and similarly here I am writing the word of here physics. So if I see through this glass slab, so the letters appears to be big in size or rising upward. Am I right? The letters appears to be becoming raised. So the glass slab. Okay. So in all these cases, what actually happens? That we'll discuss. Okay. So the discussion I will tell you here. What is happening here in this case? Okay. So here, so this is the taken here from glass surface, and when you keep coin here at the bottom of the vessel, and you are observing from here. From here you are observing. Okay, from through eye you are observing. The same point, so the light rays goes straight away. It goes straight. The same thing when coin is placed. Okay, when coin is placed, when we keep this coin in water surface, when you keep this coin in water surface, so here you're observing from this point. Okay, you're observing from this point. Actually, the light ray which is coming from here, for example, one of the light rays is coming like this. So it is coming from water to air. So it will not go straight line, but it will go somewhere. It goes like it bends like this. So this light ray appears to be coming from here. So this appears to be raised. The coin appears to be raised. So this is this light ray is bending here. It is going from not going straight line, but is going here in bending here. So the reason for refraction of light here, so we can now define, okay, now we are going to define the term called refraction of light. So what do you mean by refraction of light? Okay, alright. Now here we define about refraction of light. So it is defined as it is the phenomena. It is the phenomenon of change. It is the phenomenon of change in the speed of light. In the speed of light when it goes from one medium to another medium. So it is the phenomenon of change in the speed of light when it goes from one medium to another medium. Here one medium means it may be from water to air, or from glass to water, or glass to air. That involves here. Glass is one medium here, water is one medium here. So it is the phenomenon of change in the speed of light when it goes, that means light goes from one medium to another medium, results in the change in the direction of light. In the direction of light. In the direction of light is called refraction of light. A refraction of light. So here refraction of light involves bending of light. Here refraction involves bending of light. Bending of light at the interface. At the interface of two media. That's very important here. So refraction of light, the definition says that it is a phenomenon of change, the speed of light. Here, remember here, when light travels from here is water, here water medium is there. When light travels, if you keep pencil here, or if you keep coin here, the light is coming from here. What will come from here? It is coming from water. Coming from water here. When coming water here, it changes its direction. It changes its direction. Remember here. So it is a phenomenon of change in the speed of light when it goes from one medium to another medium. So results in the change the direction of light is called refraction of light. Here one more thing, that in refraction it involves that there is a change in the speed of light when it goes from one medium to another medium, and also it involves called bending of light. Here I will show you about two cases. Okay, I will show you. So let us see about how refraction takes place. So I will explain how refraction takes place. For example, you take this one here. XY is a one plane surface. Okay, and you draw normal to this one. Or normal to this one. So drawing normal to this one line, and here, and this is to assume that this is a rarer medium, and this is called denser medium. For example, this medium is filled with any other medium, like it is maybe filled with a material. Right. So this is a denser medium, and this is a rarer medium. Now the light ray is coming from here. The light ray is coming from denser medium, from rarer medium. from direct medium to denser medium. So previously we know that the bending of pencil is because the light ray is coming from water to air medium. Here also that the light ray is coming from rarer medium to denser medium. What is rarer? What is denser? So as the light is traveling with two different mediums, instead of going straight line, it may bend towards the normal or away from the normal. So I will explain you this one in my later classes. Okay. So now speed of light in this medium is v1 and speed of light in this medium is v2. Right? So where the speed of light, generally if the speed of light v2 is less than v1 means then v2 will be called as a denser medium and v1 will be called as a rarer medium. So you have to remember that if the speed of light decreases in a given medium means that is denser medium, the speed of light is more in that medium means it is a rarer medium. Now the light ray is coming from rarer medium to denser medium, because in this case the speed of v2 is less than the speed of v1, so we consider that the light is it is denser medium and it is rarer medium. So in this case the light is bending towards the normal here. Okay. And here another case, let us see here. Another case I will show this one. So in this case, so this is xy surface, xy, and here we have taken normal, and now reverse you take. Now this is called denser medium, and this is called rarer medium, and here velocity is v1, velocity is v2, and if you take assume that this is another surface filled up of water or glass. Okay, the light ray is coming from here. Light ray is coming from denser and it is entering into rarer medium. It bends away from the normal. So the light, instead of going straight direction, it deviates its path. So remember, in two cases here, there are two cases are there. In the first case, the light is coming from rarer medium to denser medium. In the second case, the light is coming from denser to rarer medium. So here there is some difference is there. Both the cases. In the first case, the light is bending towards the normal. In the second case, the light is bending away from the normal. So this line will be called as normal here. So why there is a change in the direction of light? Instead of going in this direction, it is going like this. Instead of going in this direction, it is going like this. Why this change in the direction of light means? Because there is a change in the speed of light when light goes from one medium to the another medium. That you have to basically to be remembered with a punchline in this lesson, that whenever light travels from one medium to another medium, that is from water to glass or water to air or glass to air, means there is a change in the speed of light. That means speed can be increased or decreased. Because of the decrease in the speed of light, light bends. This is the basic definition about refraction of light. So refraction of light involves there is change in the speed of light, means speed of light can be increased or decreased, and because of this one the light bends at a separation of two media. This is called a refraction of light. I hope you understood very well. Okay, right? Okay. Now we will define the term called absolute refractive index. So what do you mean by absolute refractive index? Let us discuss about this one. Absolute refractive index. So denoted by a letter called n. So it is defined as speed of light in vacuum to the speed of light in a given medium. So remember that absolute refractive index is denoted by letter n. It is defined as the speed of light in vacuum to the speed of light in a given medium. So speed of light in vacuum is denoted by letter called c, and speed of light in given medium denoted by letter p. Therefore, this absolute refractive index is defined as the C by V. Very, very important formula. How means? We can say like this. For example, this is one medium we are having, glass slab. This is a glass slab, simple glass slab. So in this one, so here this is a glass slab. The light ray is coming from here like this. It is coming like this, and it bends in this direction. It bends. So here this is called air, and this is called glass. So speed of light in air or vacuum, that is C. Speed of light in glass is called V here. So there is a term called absolute refractive index, defines as the speed of light in vacuum to the speed of light in a given medium. So speed of light C in vacuum, its value will be 3 into 10 to the power of 8 meter per second. Very, very, very important its values. And here the value of refractive index gives you an idea that with how much speed the light is going in a given medium, whether it is going fast or slow. The value, here the value of n, if the value of speed is n high, means it indicates that in that given medium the speed of light is low, it goes with less speed. If n is small, means it indicates the speed of light is very more. So here the n will give you that with how much the light is going, whether fast or slow in a given medium, it gives you that. For example, I will clarify you that the refractive index of glass is 4 by 3. 4 by 3. The refractive index of glass is how much? 4 by 3. So what is the meaning of this? Let us assume that. So we know the refractive index formula. What is that? When n is equal to C by V. So refractive index of glass how much is given? 4 by 3. So what we want to find the velocity of light in this glass. So V is equal to C by n. So C by n means how much we got? 4 by 3. That is equal to 3 by 4 of C. Okay, that means velocity of light in glass is 3 by 4 of the speed of light in vacuum. And another case I will give you, another example I will give you that. For example, refractive index of this is a refractive index of water, and refractive index of glass I am taking about called okay, we will take here 3 by 2 we can take. Refractive index of glass how much? 3 by 2. What is the meaning of this? That means we know that refractive index is equal formula C by V. We want to find about V. So V is equal to write as C by n. That is C by n. How much it is? 3 by 2. 3 by 2. That means we will get 2 by 3 into speed of light. That is 2 by 3 into C means 3 into 10 to the power of 8. 3 cancels. We will get that 2 into 10 to the power of 8 meter per second. That means velocity of light in glass, it is how much it is? 2 into 10 to the power of 8 meter per second. So the value of refractive index of gives you that with how much fast or slow it is going about. That we call as a absolute refractive index. What we call? Absolute refractive index. Right? Now, okay, dear students, now we will study about another definition called relative refractive index. Previously we studied about absolute refractive index. Now we will study about called relative refractive index. So here, relative refractive index. So here, what is the meaning of this relative refractive index? We will define as relative refractive index as a refractive index of one medium with respect to another medium. That is important here. That means refractive index of glass with respect to water, refractive index of air with respect to glass, how much it is. So we can define as a, that means refractive index of one medium with respect to another medium is defined as the ratio of and as ratio of speed of light in the first medium to the speed of light in the second medium. So it's very important definition that which says that refractive index of one medium with respect to another medium is defined as the speed of light in the first medium to the speed of light in the second medium. For example, here we are having one glass slab. Okay, now this is the glass slab here. Light is going from, this is one medium and this is another medium, first medium. The light is going from one medium to the another medium. The light is going from one medium to another medium. This is the air medium, this is the glass medium. So we are having different medium. So here that means refractive index of one medium, that refractive index of air to the glass, or sometimes glass to water. In many cases it is there. So we can define as the refractive index of one medium with respect to another medium is defined as speed of light. The speed of light in the first medium, that is v1, to the speed of light in the second medium. So we define as a like this, refractive index of second with respect to first. Because the light is going from where? 1 to 2. Light is going from 1 to 2. So we define as a velocity of light in the first medium to the velocity of light in the second medium. So this definition we call as a relative refractive index. Okay, relative refractive index. So here, to get here much more clarity here. Now, this is the whole equation. Both cases you divide by C. Let us see here. That means here N12 is equal to V1 by C. We got divided here, and similarly V2 by C divided. So we know that N21 V1 by C is nothing but 1 by N1. V2 by C is nothing but called 1 by N2. So if you do mathematically means N2 go outside, N1 will come outside. So we got N2 by N1, that's equal to V1 by V2. This is the formula for refractive index of one medium with respect to second medium. So very important here, refractive index of one medium with respect to second medium, that's equal to N2 by N1 is equal to V1 by V2. So very because this help you to compare with the other mediums, with water or glass or kerosene or turpentine or Canada balsam or any other materials. We can compare with this. So this is a very important topic about relative refractive index, which says that the refractive index of one medium with respect to another medium, is equal to speed of light in the first medium to the speed of light in the second medium. So very important form, that is N2, N1 is equal to N2 by N1 is equal to V1 by V2. Okay, thank you one and all.